Your small spacecraft drifts quietly through the darkness of deep space. Outside your window, the stars glow faintly, distant and steady. The hum of the ship's instruments is barely perceptible, and there is only the soft, constant movement of time as you float through the vast emptiness. As you settle into your seat, the gentle rhythm of your journey begins. Your eyes may be closed, or simply half open, letting the stillness wrap around you. In this calm journey, you'll explore the origins of our solar system, this place we call home, and quietly ask, how did it come to be, and what does it reveal about our universe? The question is simple yet profound. How did the solar system form, and what processes shape the planets, the sun, and everything in between? As we explore this, we'll glide slowly through time and space, uncovering the steps and mysteries of our cosmic home. You're floating in a small, quiet spacecraft, far from Earth, and yet the story of our solar system begins here, right beneath your feet. You feel the weightlessness of space, the sensation of being detached from everything familiar, as your journey begins to unfold. You are not alone, though. This story is the work of countless scientists, who have spent lifetimes gathering knowledge about the world above us. From the first early guesses to the most advanced space missions, each discovery has built on the one before it, forming the picture of how the solar system came to be. Let us start with the basic building blocks, those fundamental ideas that formed the first glimpses of the story. The very earliest thoughts about the origin of the solar system came from the ancient Greeks, who wondered about the heavens and their movements. But it wasn't until the early 18th century that a more scientific idea began to take shape. In 1735, a man named Immanuel Kant, a philosopher from Germany, proposed a theory. He suggested that our solar system might have formed from a large, spinning cloud of gas and dust. This cloud, he said, collapsed under its own gravity, slowly flattening into a disk. The sun formed at the center, and the planets and other smaller bodies formed from the remaining material. It was a bold idea, one that would lay the groundwork for generations of scientists to come. Not long after, another scientist, Pierre-Simon Laplace, built on Kant's theory, suggesting that the sun's gravitational pull caused the cloud to spin faster as it collapsed. Over time, the material in the disk clumped together, forming the planets. This theory would become known as the nebular hypothesis, and for many years, it was the most widely accepted explanation for the formation of the solar system. Yet, as we know now, the story is far more complex than it once seemed. Through centuries of study, advances in technology, and brave explorations into space, scientists have uncovered layers upon layers of information that have transformed our understanding of how our cosmic home came into being. You may wonder how scientists gather this knowledge. How do we know what happened billions of years ago, before the first people walked the Earth? The answer lies in the tools we've developed: telescopes that peer deep into space, robotic spacecraft that visit distant planets, and even the study of ancient rocks here on Earth. Each discovery brings us closer to a complete understanding, though the journey is far from over. As your spacecraft continues its quiet drift through the stars, imagine what it must have been like in those early days, when the solar system was just beginning to take shape. The sun was still forming, and the planets were little more than dust and gas. These early moments, hidden far in the past, shaped everything that followed. Tonight, as we drift through space, we'll try to uncover some of the secrets of those first moments. Your spacecraft moves silently through the vastness of space, its path steady, gliding past the shimmering constellations. Outside, the Milky Way stretches endlessly across the dark canvas of the universe, a river of stars so far away it almost seems timeless. As you float, the hum of the ship's instruments is your only companion. There's no rush here, no hurry, just a calm and steady journey through the past. As we continue this gentle exploration of the solar system's origins, let's move forward in time, when the first tools of modern science began to refine our understanding. The nebular hypothesis, proposed so long ago, was the beginning, but it was far from the whole story. The theories of Kant and Laplace paved the way, but it would take centuries of observation, experimentation, and discovery to see the details more clearly. One of the most important breakthroughs came in the early 20th century, with the advent of powerful telescopes and advancements in the study of the stars. With these tools, scientists were able to look farther into space, and slowly, they began to uncover new clues. But it wasn't just the stars they were looking at, they turned their eyes toward other planets, and especially toward our own. In the late 1930s, astronomer Gerard Kuiper proposed a significant addition to the nebular theory, the idea that planets form in a disk of gas and dust that surrounds a newborn star. He suggested that the outer planets, like Jupiter and Saturn, formed farther from the Sun, where it was cooler, and gathered their mass from icy material that condensed there. In contrast, the inner planets, like Earth and Venus, were composed mostly of rock and metal, forming closer to the Sun, where it was too warm for ices to survive. This idea was crucial. It added a layer of complexity to the nebular hypothesis, suggesting that temperature played a major role in determining the makeup of the planets. And yet, despite this insight, scientists still had many questions. How did these icy outer planets form? How did the gas giants, so massive and so far from the Sun, come to exist? And why, despite the theory's elegance, did the formation of the solar system seem so chaotic? As the years passed, a new generation of scientists began to tackle these questions, aided by increasingly sophisticated technology. In the 1970s, space exploration was in full swing. NASA's Voyager spacecraft, launched in 1977, sent back detailed images and data from Jupiter and Saturn, revolutionizing our understanding of the outer solar system. These distant worlds, once beyond reach, were now close enough to study in detail. The Voyagers provided evidence that many of the theories about the solar system's formation were correct, but they also revealed unexpected surprises. For example, the moons of Jupiter, some of which appeared to be the size of small planets themselves, were unlike anything scientists had anticipated. The icy surface of Europa, one of Jupiter's moons, hinted at the possibility of liquid oceans beneath the frozen crust, a discovery that would lead to many questions about the potential for life beyond Earth. But it was not just the gas giants that surprised scientists. The study of comets and asteroids, especially with missions like NASA's Stardust and OSIRIS-Rx, has helped to refine our picture of the early solar system. These small, icy bodies are thought to be remnants from the formation of the solar system, frozen time capsules that contain clues to the materials that were present in the early solar nebula. The spacecraft's instruments hum gently, transmitting the results of the latest observations, each one revealing more details. Through these missions, scientists have been able to trace the paths of molecules and minerals that help to form the planets. Each new discovery deepens our understanding of how our solar system came to be. We now know that the solar system's formation was not a simple process of dust and gas coming together. It was a much more complicated and dynamic event, shaped by the forces of gravity, temperature, and time. As you drift through the quiet void of space, you might wonder what all this means for us. After all, we are here, on a small planet orbiting an ordinary star in a vast and ancient universe. But the story of the solar system's origins is also the story of Earth, of how life began, of how we came to be. Understanding this history helps us understand not only where we come from, but how we fit into the greater cosmos. Now, with the tools of modern science, we've come to realize that the formation of the solar system was not just about a cloud of gas and dust collapsing. It was also about the powerful forces that shaped the planets. Gravity, of course, but also other factors, like the solar wind, a stream of charged particles released by the young sun. The solar wind cleared out much of the surrounding gas and dust, stopping the planets from growing any larger. Yet, this same wind also played a role in shaping the orbits and sizes of the planets, further complicating the process. As your spacecraft floats on through the stillness of space, take a moment to consider this: the solar system is not just a random collection of objects. It is a finely tuned system, shaped by the forces of nature in ways we are still working to understand. And though we know much, there is still so much left to discover. The search for answers continues. Your spacecraft drifts onward, passing through the quiet expanse of space. The stars are still distant, flickering like silent beacons, while your instruments hum softly, guiding you along this peaceful journey. With each moment, your mind travels further into the past, piecing together the story of how the solar system took shape, how it became the home we now know. We've already seen how scientists, with their curiosity and tools, have uncovered clues about the origins of the solar system. We've touched on some of the major discoveries, from the early nebular hypothesis to the refinement of planetary formation theories. But even as we piece these parts together, new questions continue to arise, prompting us to look deeper into the cosmic puzzle. One of the great mysteries we now face is understanding how the solar system's inner planets formed. These small, rocky worlds, Mercury, Venus, Earth, and Mars, seem so different from the gas giants like Jupiter and Saturn, yet they, too, share a common origin. Why are the inner planets so much smaller and denser than their distant neighbors? Why do they have so much less gas and ice? And what happened to the material that didn't become planets? Scientists have made great strides in answering these questions, thanks to the ongoing study of our solar system's building blocks. One key piece of the puzzle comes from studying meteorites, those ancient rocks that fall to Earth from space. These meteorites contain traces of the same materials that once swirled around the Sun as it was forming, and they provide a direct link to the early days of the solar system. They reveal the different types of material present at various distances from the Sun, giving us clues about where each planet's ingredients came from. For example, studies of meteorites have shown that some of the oldest material in the solar system, called chondrites, came from the inner regions where the rocky planets would eventually form. Other materials, like icy comets, came from the outer reaches of the solar system, where the gas giants took shape. This distribution of materials helped to shape the planet's composition and their size. The inner planets, with their proximity to the Sun, had access to heavier, rocky materials, while the outer planets could gather lighter gases and ices. Understanding this process helps to explain why the inner planets are so different from the gas giants. At the same time, space missions like NASA's Juno spacecraft currently orbiting Jupiter, have given us new insights into the giant planets. Juno's data has revealed how Jupiter's magnetic field, atmosphere, and interior are connected in ways that scientists didn't fully expect. By studying Jupiter so closely, scientists hope to better understand how it formed, and how its early history shaped the rest of the solar system. Yet even with all of these discoveries, one fundamental question remains: how did our solar system end up with its current arrangement? Why do some planets orbit close to the Sun, while others are far away? And why do we have such a variety of worlds, from small rocky planets to gas giants and icy moons? The answer to this question lies in the chaotic early history of the solar system, a time when planets were still forming, and the orbits of many objects were unstable. In the first few 100 million years of the solar system's existence, gravity was a powerful force, pulling objects together and sending them on wild orbits. During this time, the planets were not as settled as they are now. Some planets were even knocked out of their original orbits, while others collided or exchanged material in dramatic ways. This period of chaotic motion, sometimes referred to as the Late Heavy Bombardment, may have played a key role in shaping the solar system's final configuration. The impacts of comets and asteroids during this time could have both created craters on the planets and influenced their orbits, making them more stable over time. The chaos eventually gave way to order, but not without leaving its mark. As the planets settled into their current orbits, they did so with the lingering effects of these ancient collisions and disturbances. The size of the planets, their compositions, and their positions in the solar system were all determined, in part, by these early events. Your spacecraft glides silently through the stars, drifting farther into the past, reflecting on this period of tumultuous change. Even though it was a time of upheaval, it laid the groundwork for the stable system we know today. And while many of the details of this chaotic phase are still unknown, scientists continue to study the remnants of this early solar system, piecing together the story one discovery at a time. The questions may be endless, but each one brings us closer to understanding our place in the universe. And as you float in your quiet seat, drifting through the stars, remember that we are still learning. Each mission, each new piece of data, adds to the picture of the solar system's birth, helping us understand not only the history of our cosmic home but also the possibilities of other worlds, and the paths they may have followed to become what they are today. The quiet hum of the spacecraft's instruments is your constant companion, a gentle reminder that the journey continues. The stars remain distant, their light so old and faint that it feels as though time itself is stretching into infinity. Your spacecraft drifts effortlessly through the stillness, and with each passing moment, the past seems to open up before you, layer after layer of the story of our solar system. As we've explored the origins and formation of the solar system, we've uncovered many secrets, but there are still mysteries that remain. For all that we've learned, there are still questions that scientists are actively trying to answer. These questions may not be immediately obvious, but they are at the heart of our quest to understand not only the solar system's formation but also its future. One of the biggest questions still facing scientists today is about the detailed processes that shape the solar system's planets. The story of how the planets formed is, in many ways, still being written. We've learned much about the ingredients, the gas, dust, and ice that formed the solar system, but we don't fully understand how these ingredients came together to create the exact planets we see today. Was the formation of the planets a smooth, orderly process, or was it more chaotic, with planets growing rapidly in some areas and slowly in others? How did the gas giants form so far from the Sun, and why did they grow so much larger than the rocky planets? Some of these questions are being tackled by space missions and observations that are still ongoing. For example, the James Webb Space Telescope, launched recently, promises to give us even more detailed observations of exoplanet systems, planets that orbit stars beyond our own. By comparing these distant systems with our own, we may be able to learn more about the formation process. Could other stars have formed similar solar systems, or are we unique in the way our planets took shape? In addition, the study of the Kuiper Belt, a region of icy objects beyond Neptune, is helping to refine our understanding of the solar system's formation. Missions like NASA's New Horizons, which flew by Pluto and is now venturing deeper into the Kuiper Belt, are revealing clues about the early solar system, about how the outer planets may have gathered their material and how small bodies like comets might have played a role in shaping the orbits of the larger planets. There are also still lingering questions about the early Earth itself. How exactly did Earth's atmosphere form? How did liquid water come to be here, and how did the planet maintain temperatures suitable for life? Some scientists believe that our planet's composition, its water, and even its magnetic field may have been shaped by impacts from asteroids and comets during the early solar system's chaotic period. These impacts could have delivered water and other vital ingredients, setting the stage for life. The origin of life on Earth remains another open question. While we know that life began here at some point, the precise moment of its inception, and the conditions that allowed it to take hold, remain a mystery. Some scientists speculate that life may have come from the deep ocean vents, where the necessary chemicals could have come together in a warm, protected environment. Others believe that life may have come from elsewhere, perhaps from a comet or asteroid, carrying the building blocks of life to Earth. This question, too, is still unanswered, but each year, new discoveries bring us closer to understanding it. As your spacecraft continues its journey through the stars, you might feel a sense of quiet awe at the magnitude of these questions, and the effort required to answer them. These are not just scientific inquiries, they are questions that touch on the very nature of life, the Earth, and the universe itself. We are all part of this story, a story that is still unfolding. Yet even as we search for answers, there's something beautiful in the uncertainty. The search itself, the journey through space and time, is just as important as the answers we find along the way. Each discovery brings us a little closer to understanding not just how our solar system was formed, but what it means to exist in such a vast and mysterious universe. The answers may not come quickly, and some may remain out of reach for a time. But as you sit quietly, suspended in your seat aboard the spacecraft, remember that this journey is about more than just facts and data. It's about the joy of discovery, the sense of wonder that comes with learning more about the world we live in, and the quiet satisfaction of knowing that our understanding is always growing, even if it takes time. And now, as we approach the final moments of our journey tonight, we begin to slow down, drifting gently toward the peaceful stillness of the present. Your spacecraft remains a quiet observer, floating silently among the stars, as we reflect on the journey of our solar system, from its chaotic beginnings to its current calm. You don't need to hold on to any of this. It's enough simply to listen, to drift, and to let the vastness of space guide you toward the quiet end of this journey. As the stars continue to shine above, their light ever so ancient, we can rest in the knowledge that the story of the solar system is far from over. And in the end, you don't need to remember everything, for the journey itself is enough. You can simply float, quiet and still, as the cosmos continues to unfold. The spacecraft's gentle hum becomes softer now, and the stars drift slowly by. If sleep hasn't found you yet, you can simply stay here, floating in the dark, while the quiet expanse of space continues its timeless journey. Your spacecraft moves effortlessly through the stillness, the hum of its instruments a soft, constant presence in the background. The stars outside are distant and calm, a quiet reminder of the vastness that surrounds you. As you continue your journey through this cosmic night, the story of our solar system lingers in the air, a tale of dust, gas, and the slow shaping of worlds. You've already learned about the early history of the solar system, the swirling nebula of gas and dust that gave rise to the sun and planets, the chaotic formation of worlds, and the gradual settling of a system that eventually became stable and familiar. But even as we rest in the comfort of what we know, there's more to this story, more to explore, more to understand, and more to wonder about. One of the most fascinating aspects of our solar system's formation is the role of smaller bodies, comets, asteroids, and the many other objects that populate the space between the planets. These small bodies may not seem as important as the large planets, but they hold vital clues to understanding the early solar system and its evolution. Take, for example, the asteroid belt that lies between Mars and Jupiter. This region is home to thousands of rocky bodies, some no larger than pebbles, others as large as moons. Scientists believe that the asteroid belt contains remnants of the early solar system, fragments of material that never coalesced into planets. These objects are ancient, unchanged since the time when the planets were still forming, and they hold a wealth of information about the conditions in the early solar system. The study of asteroids has been a key part of modern space exploration. Missions like NASA's OSIRIS-Rx, which recently collected a sample from the asteroid Bennu, have given scientists a glimpse into this ancient material. The samples returned from Bennu will help scientists better understand the composition of the early solar system, shedding light on the types of materials that were present when the planets were forming. What's even more remarkable is that some scientists believe that these small bodies may have played a role in delivering water and organic molecules to Earth, ingredients essential for life. Beyond the asteroid belt, further out in the solar system, we find the Kuiper belt and the Oort cloud, two vast regions filled with icy bodies that are remnants of the solar system's formation. The Kuiper belt, which includes Pluto and other dwarf planets, contains icy objects that formed in the outer reaches of the solar system. The Oort cloud, located much farther out, is a vast, spherical shell of icy bodies thought to be the source of long-period comets. These distant, frozen objects are windows into the early solar system, preserving clues to the way the outer planets formed and how they shaped the system. These small, distant bodies may seem insignificant, but they are far from it. They are the keys to understanding the earliest moments of the solar system, moments when the sun was young, and the planets were still taking shape. By studying these ancient objects, scientists can piece together the timeline of the solar system's formation, and perhaps even unlock the secrets of its future. As your spacecraft drifts through the calm of space, imagine the quiet, frozen worlds that lie far beyond the planets you know. Imagine the icy comets that travel along their long, elliptical orbits, tracing paths that stretch across the entire solar system. These are the remnants of the early days, carrying with them the ingredients of the solar system's birth. And yet, even as we explore these ancient objects, there is still so much we don't know. How did the objects in the Kuiper belt form? Why do some asteroids have such strange, irregular shapes? Why are some comets so rich in organic material, while others are not? The answers to these questions remain elusive, but each mission, each new discovery, brings us closer to understanding the solar system in its entirety. The questions we still face remind us that the solar system's story is not just about its past, but its future as well. As we look forward, we wonder what will become of this place we call home. Will we continue to explore the stars, seeking out new worlds and understanding the cosmic forces that shape them? What will we find when we turn our gaze beyond the planets to the vast reaches of space? And how will the solar system continue to evolve in the coming millennia? Even as these questions remain unanswered, there is something peaceful in knowing that the journey of discovery is far from over. The quiet hum of the spacecraft, the distant stars, the stillness of space, all of these remind us that we are part of something much larger, something that has been unfolding for billions of years and will continue for billions more. As your spacecraft drifts through the night, you may feel a sense of comfort in the knowledge that, while the story of the solar system is vast and complex, it is also a story that we are part of. Each of us, in our own way, is connected to the stars, to the planets, to the dust and gas that formed our cosmic home. And while we may not have all the answers, we are, at this very moment, contributing to the unfolding story of the universe. You don't need to hold on to any of these details. They are simply part of the grand tapestry of the cosmos. Let them fade into the quiet hum of the spacecraft as you drift deeper into space. The stars will continue to shine, distant and steady, as they have for eons, and as you drift towards sleep, you can let the calm of space wrap around you, knowing that this journey, like the solar system story, is ongoing, quiet, peaceful, and ever-expanding. Your spacecraft continues its peaceful drift through the vast emptiness of space. The stars flicker faintly in the distance, their light traveling across the cosmos, a reminder of the immense distances that separate us from the farthest reaches of the universe. The soft hum of the ship's instruments creates a calming rhythm, a gentle guide as you continue your journey through time and space. As we reflect on the story of the solar system's formation, the pieces we've gathered start to fit together into a picture of a dynamic, living system, one that has evolved over billions of years. We've seen how the early solar system was a place of chaos, with gravity pulling objects together and collisions shaping the planets. We've watched as the planets, moons, and smaller bodies took form, each one a piece of a much larger puzzle. But even as we've learned about how the solar system was born, there's another crucial piece to this story: the way the sun, the beating heart of our solar system, shaped everything around it. The sun is not just a source of light and warmth for the planets, it is the force that has held the entire system together, a constant, stable presence in a universe full of change. The sun, like the rest of the solar system, began its life as part of a much larger cloud of gas and dust. This cloud, made up of the remnants of older stars, began to collapse under its own gravity, eventually forming the sun at its center. The process of the sun's birth was a violent one. As the cloud collapsed, it heated up, and the pressure at its center grew immense. Eventually, nuclear fusion began in the sun's core. This process, in which hydrogen atoms are fused together to form helium, releases enormous amounts of energy. This energy created the light and heat that would support life on Earth and shape the evolution of the entire solar system. But even as the sun was forming, it was already having an impact on the solar system's development. The energy from the sun's early radiation, known as the solar wind, pushed away much of the gas and dust that surrounded the newborn star. This solar wind played a crucial role in shaping the solar system, helping to clear away the material that might have otherwise formed additional planets. It also influenced the formation of the planets themselves, particularly the gas giants, by pushing lighter elements like hydrogen and helium outward, where they could form the large, gassy planets that we see today. The Sun's influence continues to this day. Every planet in the solar system is bound to the Sun by gravity, each one following its own orbit through the vast reaches of space. The Sun's energy, its light and warmth, sustains life on Earth, and its gravitational pull keeps the planets in their orbits, preventing them from drifting off into space. Yet the Sun is not a static, unchanging object. It, too, undergoes a life cycle. Over the course of billions of years, the Sun has gradually grown brighter, warming the planets and changing the conditions on Earth. In the future, it will continue to evolve, eventually expanding into a red giant and shedding its outer layers, leaving behind a dense, cooling core. This process will mark the end of life as we know it here on Earth, but it will also provide a new beginning for the rest of the universe, spreading the elements needed for the formation of new stars and planets. As you float through space, imagining the vastness of time and the changes that the Sun will undergo, there is something humbling in knowing that our solar system, like all things, is in a constant state of flux. The birth and eventual death of the Sun are part of a much larger cycle, one that has been unfolding for billions of years and will continue long after we're gone. But the Sun's story is not just about the end. It is also about the present, the moment we are in right now. The light that reaches us today is the same light that has traveled across the cosmos for billions of years. The warmth we feel on Earth is a gift from the Sun, a constant source of energy that has allowed life to flourish. In this moment, as you sit aboard your spacecraft, you are bathed in the same light that has warmed the Earth for as long as life has existed. You are part of this ongoing story, this cycle of birth, life, and eventual change. Even as we explore the Sun's influence, we are reminded of the way all the pieces of the solar system fit together, how each planet, moon, and comet plays a role in this grand, cosmic dance. Each object in the solar system is connected to the others, bound by the Sun's gravity, shaped by the forces of space and time. As you float silently in your seat, the spacecraft's gentle hum a constant presence, you may begin to sense how everything, planets, moons, comets, and the Sun itself, is part of a larger story. A story that stretches back billions of years and will continue long into the future. A story of formation, destruction, and rebirth. A story that we, as humans, are just beginning to understand. You don't need to hold on to every detail. As you drift deeper into space, simply allow the quiet beauty of the moment to wash over you. The stars continue to shine, their light a reminder of the endlessness of time and the vastness of the universe. And as your spacecraft glides onward, you can let go of all the questions, all the mysteries, and simply rest in the knowledge that you are part of something much larger, something timeless and eternal. If sleep has not yet found you, let the calm of space and the gentle hum of the ship guide you into peaceful rest. The journey of discovery is far from over, but for now, you can simply float in the quiet dark, drifting through the stars, and let sleep take you where it will. Your spacecraft moves silently through the infinite expanse of space, its steady hum providing a comforting rhythm. The stars outside are still distant, their twinkling light soft and constant, as though the entire universe is at rest. The journey continues, but now, you begin to feel the quiet, soothing embrace of time as it stretches before you. The solar system, our cosmic home, is a story of transformation, one that will echo through the ages, long after tonight's journey is over. As you drift, you might find your mind returning to the question that has guided us through these quiet moments: how did this all come to be? How did our solar system form, and how do we, on this small world we call Earth, fit into the greater story of the universe? In many ways, the solar system story is one of quiet persistence, a constant, gradual process of change. From the moment the sun began to form in the cold depths of space, it set into motion the forces that would shape everything in its domain. The planets, moons, comets, and asteroids are all part of this story, each one a reflection of the history that has unfolded over billions of years. The forces that shaped the solar system were not just the large, sweeping events like the formation of planets, but also the smaller, more delicate interactions that happened over time. The gravitational dance of the planets, their moons, and other objects has led to a system that, while stable today, was once a chaotic and unpredictable place. One of the more recent revelations has been the discovery that the planets didn't always follow the calm, predictable orbits that we see today. In the early days, the solar system was far more chaotic. Planets were still forming, and their orbits were constantly disturbed by the gravitational influences of nearby worlds. Some planets were knocked out of their original orbits, while others collided or exchanged material in dramatic ways. In the midst of this cosmic turmoil, something fascinating began to take shape. The outer planets, the gas giants, Jupiter, Saturn, Uranus, and Neptune, began to play a critical role in shaping the solar system's final configuration. Their massive sizes and strong gravitational pulls helped to clear the space around them, gathering up material that might have formed additional planets or moons. But they also sent other objects, comets and asteroids, hurtling through the inner solar system, where they had the potential to collide with the smaller rocky planets. These interactions, although violent and chaotic, played a key role in shaping the solar system into what it is today. They set the stage for the quieter system we now observe, a place where planets follow their orbits around the sun in peaceful harmony. The impacts that occurred billions of years ago, while destructive at the time, also contributed to the creation of some of the features we see today. For example, Earth's moon is thought to have formed from a massive collision with a Mars-sized body, a violent event that led to the formation of the satellite that we now depend on. Yet, as we reflect on this, we are reminded that the solar system we know is just one possible configuration, just one result of a series of interconnected events. The solar system we see today is shaped by both chance and necessity, by forces beyond our control and yet tied to the very fabric of the universe itself. Even as we understand more about how the solar system formed, there are still many mysteries left to uncover. What other solar systems are out there? How do they compare to our own? Are there other Earth-like planets in the universe, waiting to be discovered? How do the processes we see in our own system play out in distant stars and galaxies? As we gaze out at the stars, we are reminded that we are just beginning to understand our place in the cosmos. Each new discovery, each new mission to distant planets and moons, brings us closer to answering these questions. But the beauty of it all is that, even as we